Hey everyone, this mini video is going to be a review over section 3.3 that we did in class to help you remember how to find the vertex form of a quadratic function. So the goal for this video is every time being able to get an equation in this format. This is vertex form. Now you can see the vertex in this equation. That is h and k is our vertex. But keep in mind when it asks for vertex form, they're actually asking for an entire equation. So let's refresh our memory on what this equation means, first of all. So remember the A, first of all, does two things. It can reflect the graph if it's negative. Also, if the A is a number bigger than 1, like 2, 3, 4, then it'll stretch that graph skinnier. If the A is a fraction, like 1/2, 1/4, it's going to compress the graph vertically flatter. H and K, as I said before, is our vertex, so that's very helpful to use when you're graphing your equation. So keep those features in mind when we're given the information. So number 10 on your review says, write an equation of a function with a vertex at -1, 5, and a point at 0, 8, and it's opening upward. So let's draw a mini graph of the information they gave us so we can kind of get an idea of what they're saying. So they said that there's a vertex at -1 and +5. So that'll be about right here. And there's a point at 0, 8. Let me get a different color. And 0, 8, 5, 6, 7, 8 will be up here somewhere. So I'm just drawing a little sketch. And it's opening upward. So something like that. So you have many choices when you're doing this. Now you could go ahead and plug in your vertex in for H and K, and you can also then use the point to plug in for X and Y. Remember, f of X is the same as Y. Another way to do it would be to reflect this point over here. You then have 3 points. Remember, anytime you have 3 points, you can do a linear regression and find the equation in your calculator and then rearrange it to vertex form. What I'm going to do is go ahead and plug in, because I think it's easier to plug in when you're given the vertex and a point. The key is that it's a vertex. The only thing you can plug in for H and K is when you're given a vertex. So let's do that. All right, so my H is going to be -1. My K, because this is my vertex, is going to be 5. And the point, which is, this is my X value and this is my Y value. So I'm going to plug in 8 for the Y, and I'm going to plug in 0 for the X. So the only thing I don't have here is the A. So since the A is the only thing that's missing, I can go ahead and simplify this down. And let me make sure I've got my parentheses here. There should be 1 here and 1 here to match my equation. So you'll see I plugged in 8 for the Y, brought down my A. I plugged in 0 for the X, -1 for the H. Also notice there is a minus here. I brought down that minus sign. And I plugged in 5 for the K. All right, let's simplify this down a little bit so it's a little bit easier to read. So I've got in the parentheses 0 minus a -1. Oh, and this is squared too. I forgot that little square there. So 0 minus a -1 is the same as 0 plus 1 squared. I could probably simplify that down even more, which let's do that on the next step. So 0 plus 1, 1. 1 squared is 1. So I can go ahead and simplify that whole thing down to 1. All right, I'm ready to solve for A. So first, I want to get rid of that 5. So in order to do that, I need to subtract 5 on both sides. 8 minus 5 leaves me with 3. I bring down my A times 1. A times 1 is just A. So I really don't need to bring that 1 down. So my A is 3. Now I have all the information that I need to write an equation, because the only thing you need to write an equation is you need to know what the A is, which we just found. We need to know the H, and we need to know the K, which is our vertex. We already know that. So let's go ahead and plug everything in. F of X, or you can write Y, that means the same thing. My A is 3. bring down my x, minus a -1 for my h. Minus a -1 is going to be plus 1 squared, plug in my k, of 5. So there is the equation with the given information. It has a vertex I can see at -1, 5, and I used my point of 0 and 8 to plug in to find the a value. If you did it another way using the regression, just make sure that you rearrange it to get it into vertex form if that's what they're asking for. All right, let's try another problem. It says write a quadratic function for a parabola with an axis of symmetry at x equals -2 and includes points -1, 3 and -4, 5 and opens upward. We're going to go ahead and assume they want it in vertex form since I think the answer choices are in vertex form. So I'm not going to use the answer choices because we're practicing for those short answer too on the test. But let's draw a picture first so we can see what's going on. It kind of helps us give a visual here. So if we have an axis of symmetry at x equals -2, that's going to be a whole line there at -2. So go ahead and draw an axis of symmetry in at -2. Then it tells us that it includes the points -1, 3. So let's plot that point. -1 and 3 would be about right there. And -4, 5. So -4, 2, 3, 4, 5. I kind of ran in the room. We'll be up here somewhere. And it tells us that it opens upward. We're just going to keep that opens upward in mind. It tells us in the end that we know our A has to be positive because if it's opening up, it's going to be a positive A. Remember, if you have a negative A, it's going to be flipped down. It's going to be reflected. So just kind of tuck that information in the back of your mind when we get to the end and make sure that that checks out to be true. All right, so looking at this information, I don't have the vertex. I know that it's going to be, because of my axis of symmetry, I know it's going to be -2, comma something, but I don't know the y part. So since I don't have the vertex this time, I can't just plug it into my equation like we did before. So we're really going to need a little bit more information in order to be able to solve this. One other thing that we can do is we can run a regression, but we have to have 3 points. We have 2 right now. We know we've got one at -1 and 3. We've got -4 and 5. We know there's something at -2 something, but we don't know what the other point is. But we do have an axis of symmetry. So that means that whatever point is on this side has to be on the other side as well because this is an axis of symmetry. It means it's symmetrical at both sides. So I know I have a point here. That point would be -3. Since my axis of symmetry is at -2, it's 1 over there, comma 3. So I can add that to my list, -3, 3. Maybe I can find another point too. Let's see if I've got a point at -4, 5, and I flip it over. That means I've got one up here at 0, 5. Let me add that to my list, 0, 5. All right, I have to leave this point out because I don't have the y value for right now, but we're going to come back to that. So let's put this into the stat of our calculator, run a regression. So go to stat and hit enter on edit. This is where you're going to enter your data into L1 and L2 to run the regression. All right, once you have your data entered in carefully in L1 and L2, make sure you didn't make any mistakes. Then you're going to go back to stat and you're going to arrow over once to calc. And since we're looking for a quadratic regression, choose option number 5, which is quad reg, which stands for quadratic regression. All right, then you should get an equation. Remember that your equations come out in standard form. So you're going to plug in the A, and I'm going to always round to 2 decimal places. So it's 0.67 to round to 2 decimal places, x squared. I plugged in the A. Plus the B value is 2.67 x, plug in the C, plus 5. So that is my equation. Since this one gave me a big decimal answer, I'm not going to be able to convert it very easily to vertex form, at least what we've taught you thus far in class. So this would be your answer for this answer. We can only get a standard form from what we've done so far. And I think that matches one of your answer choices on your review. So good luck on this. Remember that if you get to this part and you do need to convert to vertex form, you can always complete the square. And I'm going to go over completing the square in the video of 3.1 if you need a review on how to complete the square. So be sure you practice these on your review so you're ready for the test. Good luck.